am going to talk about resistors and Ohm's law. So what happened here? Something is plugging charges to make them to move. That is the battery that is making a current. So they are someone throwing charge with that the constant velocity is v sub d, draft velocity, is flowing through the cable. The electrical field that is inside the cable, even is a conductor, there is an electrical field inside because it's not a condition that is an equilibrium condition. The charges are moving. So in this situation, the electrical field will push the charge to move, but the charges are moving with constant velocity v sub d. And here on the material, there is what we name that the resistance that is making the charge not to go faster and faster. It goes, or the charge is moving with constant velocity v sub d. So the first definition, what is the resistivity? The resistivity is the amount of electrical field divided by the amount of density of current per unit of area and per unit of time. There is the inverse that is called the conductivity. That is sigma. The conductivity is the inverse of the resistivity. So there is a Ohm's law that Ohm's law say the input is the electrical field, the output is the density of current. You create density of current by an input that is the electrical field, and the constant of proportionality is the conductivity. So this is Ohm's law. But this is not the way that you use Ohm's law, but from here we can deduce Ohm's law. Ohm's law is only valid for certain materials, so it's not really a law. So let's go to go from this equation to this equation, V equal I by R. So how we go to this equation? Let's say that this is the cable. Let's say that they are moving, the charge are moving inside the cable. Let's say that they are positive charge, it doesn't matter. It will not affect, if it's negative charge, they will be moving to the left. Okay, positive charge moving in the direction of the electrical field, because the electrical field will produce a force, Q by E, but the material will place a force also in the opposite direction that makes these particles to move with constant velocity v sub d. So what it say, Ohm's law say that materials behave like this. The input E create an output J. The input electrical field create an output that is the density of current. So the density of current, you remember, we see in the first video, is NQV. The density of current by the area is the current, okay, and the density of current by the area by the length of the cable, will be the density by A by L by E, because what it say, this equation, is that the J is sigma by L by D. So what I have done is to multiply this equation, is in vector form, so I have put it in scalar form, that J is equal sigma by E, by the magnitude of E. The magnitude of J equals sigma by the magnitude of A, and what I have done is multiply by A by L. A, the area here, this area, A, by this length, L. Meanwhile, the charge are moving here inside the cable. So if I multiply by A by L, I realize that E by E multiplied by L is the difference in potential between these 2 points. This is delta V, the potential, the difference in potential. This is what it makes the particles to move in the direction of decreasing potential. It's going in this direction, the direction of the electrical field, in the direction of the potential that is decreasing. So the currents by L will be sigma by A by E by L, but E by L is the difference in potential. So if you play a little bit with this equation, you will find that the current I will be sigma by A divided by L by delta V if you play a little bit more, you will find that delta V is L divided by sigma by A by the current. So if you remember that one over the conductivity is the resistivity rho, so you will find rho by L by A. This is something that is intrinsically properties of the material. And this quantity, you call it the resistance. So the equation that you have finally is the Ohm's law that says that the difference in potential between the points A and V, which are the point A and V, the two points where the charge is flowing, is R by I. And this is Ohm's law, and we will apply a lot.